Hello, let us do an interesting problem. Problem which I have modeled like a JEE Advanced problem. One or more than one correct type objective question. This is the question. A cube sliding without friction along a horizontal floor hits a vertical wall with one of its faces parallel to the wall. This is the wall, this is the cube. The wall is vertical, cube is sliding on the floor and it hits the wall. The coefficient of friction between the wall and the cube is mu. The angle between the direction of velocity v of the cube and the wall is alpha. At the instant of hit, the cube was traveling in this direction with a velocity v, and this direction makes an angle alpha with the wall. This is a line parallel to the wall. With this line, velocity is making an angle alpha. That is what has been shown in the diagram. Assume that the collision does not change the magnitude of velocity of the cube perpendicular to the wall. Assume that collision does not change the magnitude of velocity of the cube perpendicular to the wall. After collision, the cube moves making an angle beta with the wall. Which of the following options regarding beta are correct? That is what you have to decode. So, I am getting out of the screen, capture the question and read it carefully, deliberate over it, you will be able to do it. Hopefully, you will be able to do it. It is slightly tricky, no doubt about it. First of all, let us do it in routine fashion, the way we solve these kind of questions in mechanics. It appears to be a similar question which many of you might have seen. So, initially before collision, the velocity component of this cube in this direction perpendicular to wall is v sin alpha, and in this direction it is v cos alpha. This is what has been given. Collision lasts for the interaction between the wall and the cube lasts for some time, let us say t naught. For t naught second, the objects, the wall and the cube interact with one another. Let us assume that. So, after time t naught, they separate. Obviously, question says that velocity, magnitude of velocity component of the cube perpendicular to the wall does not change. So, this v sin alpha, obviously it will change direction, no doubt about it. It cannot keep on moving in this direction, but the magnitude has not changed means now the component of velocity of the cube perpendicular to wall is v sin alpha in this direction. What happened to this component? The question says there is friction. In this case, friction is an impulsive force. Impulsive force means during the interaction, the wall applied a normal reaction in this direction. Because of this normal impact, the momentum of the cube changed in this direction, and that is the reason that its velocity has changed in direction. But there is a friction depends on normal reaction. The wall is static, the cube is traveling like this, so definitely there is rubbing. The cube is moving in this direction, friction has to be in this direction. And this friction is not a normal force, it is not a usual size force, it is impulsive force because it depends on normal reaction, it is directly proportional to normal reaction. Normal reaction is impulsive, therefore friction is impulsive. So, impulse of the friction is going to decrease this velocity, that is for sure. So, let us say the velocity after impact in this direction is Vy. Okay. It is difficult to understand what is exact value of n. In fact, n will be a variable force in the time interval t naught. The cube interacted with the wall for time t naught, and during that interval of t naught second, the normal reaction force may not be constant, it will not be constant in fact. So, we will not try to find the value of n, rather we will try to find value of its impulse. Obviously, change in momentum of this cube in this direction, let me call it as x and this as y. So, change in momentum of the cube in x direction is 2 mv sin alpha, isn't it? mv sin alpha in this direction, final is mv sin alpha in this direction. So, change in momentum is 2 mv sin alpha, and this will be equal to impulse of the normal force received by the cube. So, impulse of the normal force will be n dt integrated from 0 to t naught. If the interaction time is t naught second and normal reaction is variable, I mean for the small interval 0 to t naught, the normal reaction force would have varied like this. So, impulse of the normal reaction, I am writing it as n dt integrated from 0 to t naught, it will be equal to change in momentum of the cube, that is the impulse, this equation 1. Now, friction force is mu into n. So, what is impulse of friction? Impulse of friction, friction acted for t naught second only. What is impulse of friction? Friction force into dt integrated from 0 to t naught. Now, definitely it is rubbing, it is kinetic friction, it is mu into n only. So, mu into n into dt integrated from 0 to t naught. So, mu is a constant, right, and integration of n dt is this much. So, this becomes mu into 2 mv into sin alpha, right. So, this is the impulse of friction that has acted on the cube, and because of that its velocity in y direction will change. The change in momentum in y direction, if the final velocity in y direction is Vy, initial is V cos alpha, and this is change in momentum in y direction, and this will be equal to impulse of the friction. Impulse of the friction is equal to 2 times mu mv sin alpha. So, Vy will be equal to V cos alpha. I am so sorry, I have to write this with a negative sign, isn't it? This is positive direction and the impulse, friction impulse is in negative y direction. So, it will cause decrease in velocity, not increase. So, V cos alpha minus 2 mu V sin alpha, this is Vy. So, the question is asking you to find beta. What is that beta? Beta is the angle that the velocity of the cube makes after collision with the ball. So, in this direction, velocity of the cube is V sin alpha. In this direction, it is Vy that we have calculated, and we are supposed to calculate this angle. So, tan of beta is V sin alpha by Vy. So, tan of beta is V sin alpha by Vy, which is V cos alpha minus 2 mu V sin alpha. Of course, you can write it like this, tan alpha by 1 minus 2 mu tan alpha. So, this is the value of tan beta. One of the options says that tan beta is equal to tan alpha by 1 minus 2 mu tan alpha. Okay, this was quite easy, and many of you must have solved this question till this stage very easily. I am very confident about that. But what is this? If tan alpha is less than 1 by 2 mu, is this a necessary condition? Is this a necessary condition or not? This is also very obvious. Look at the denominator. Look at the denominator. If 1 minus 2 mu tan alpha is less than or equal to 0, this appears to be meaningless, isn't it? First, Let me take it to be equal to 0. Suppose this is equal to 0. This implies that beta is equal to 90 degree, pi by 2. What does it mean actually? Or what does it mean if this is negative? Which means tan alpha is greater than 1 by 2 mu. What does this mean, or what does this mean? What it means is, it may happen, think that friction coefficient is large. Just for a moment think that friction coefficient is large. Just for the sake of argument, let us imagine that this cube and the wall interacted with each other for t0 seconds. Friction is large. This velocity component, let us say, is quite small. What happens is, because friction is large, let us say before t0 second, that means consider a time interval of 0.8 t0. In this time interval only, this velocity component vanishes, it becomes 0. Try to understand. The impact lasted for t0 second. Now this is sliding on the wall, friction is large. Before the cube leaves the wall, its velocity in this direction has become 0. This can happen. When we took this equal to 0, when this is equal to 0, if you want, you can do the calculation on your own, it is not difficult at all now. If you take this condition, that means if you assume that mu is equal to 1 by 2 tan alpha, if you take this condition, you will be able to show that just at the end of t0 second, this velocity component has become 0. That means just at the moment when the cube leaves the wall, this velocity is gone. So cube will be moving in this direction only with a velocity of v sin alpha. So the angle beta will become 90 degree. Meaningful. But what does this mean? This is negative. It means that friction is so large that in 0.8 t0 or 0.7 t0 or 0.2 t0, the velocity in this direction has become 0. The way we have done mathematics, we have assumed that friction has acted for entire interval t0. अगर रियली में फ्रिक्शन t0 सेकेंड तक लगेगा जैसा हम सोच रहे हैं और बड़ा है, तो ये वेलोसिटी 0 हो गई और अभी भी फ्रिक्शन लग रहा है, तो दिस क्यूब विल एक्वायर वेलोसिटी इन दिस डायरेक्शन, which is not going to happen, which will never happen actually. The cube is traveling in this direction. If its velocity becomes 0, relative motion between the wall and the cube is over, friction will adjust itself to 0. Why will friction act in this direction? But the way we have done the calculation, we have calculated the impulse of friction for the entire interval t0, which may not be true. It may happen that in 0.5 t0 time, the velocity in this direction has become 0. So friction after that is 0. There is no friction impulse. This cube cannot move in this direction because of friction. That can never happen. It is highly illogical. So this becoming negative is actually telling you that impulse of friction has not acted for entire period of t0, but you have taken it to be acting for a period of t0. तो बेचारे मैथमेटिक्स को क्या पता, उसने vy को इधर ले लिया, which is wrong. So in this case also, if this condition is satisfied, actually the block will move in this direction only, velocity in this direction will become 0. So 1 by 2 mu is less than tan alpha. What is that? Tan alpha, have I written it correctly? Tan alpha 1 minus इज इक्वल टू 0 एंड दिस इज लेस देन 0, कुछ तो गोलमाल नहीं किया मैंने, 1/2 म्यू से tan अल्फा बड़ा है. ओके, इन दिस कंडीशन हियर इट इज नॉट रिटन करेक्टली, ये उल्टा ही लिखा है ना, tan अल्फा बड़ा है 1/2 म्यू से, tan अल्फा छोटा है. tan अल्फा अगर इससे छोटा है तो क्या tan बीटा की वैल्यू ये होगी? क्यों? क्योंकि ये कंडीशन में बीटा जो है 90 डिग्री है, ये कंडीशन में भी बीटा जो है 90 डिग्री है. बाकी ये पॉजिटिव नंबर है, दिस इज ग्रेटर देन 0, तो ऑब्वियसली जो आपने कैलकुलेट किया है tan बीटा की ये वैल्यू, ये सही है. तो देयरफॉर ऑप्शन ए इज करेक्ट. बीटा इज इक्वल टू 90 डिग्री इफ tan अल्फा इज ग्रेटर देन 1/2 म्यू. यस, दैट इज ऑल्सो राइट. tan alpha is greater than 1/2 mu, that means beta is definitely 90 degree, and beta is 90 degree if tan alpha is equal to 1/2 mu, that is also correct. This doesn't make any sense, यहाँ पे प्लस नहीं आएगा, तो A, B and C are correct answers. Hope you enjoyed it. See you in the next video.